Okay, so on to balancing equations. This is something that I really enjoy. Some students find it a little tricky at first, but you will all get there. You will all get there. And there are some tricks to it that I'm going to help you with. All right. What is a balanced chemical equation? Well, a balanced chemical equation is one that shows the ratios in which the reactants come together and products form. So what this means is you must have equal numbers of each type of atom at the beginning. Remember, that's reactants. And the end products. Now, they can change what they're bonded to. They certainly can change, like you can have carbon reacting with oxygen making carbon dioxide, or hydrogen reacting with oxygen and making water. So the chemical properties may be very different, but the number and types of atoms must remain the same. So there are a couple techniques. I have one that I really prefer. I'll talk about this one first, though. So this is the combustion of methane. And so you can take an inventory of all of your atoms. So this is unbalanced. So I count on each side. I have one carbon here, so that's equal, 1 and 1. Here I have 4 hydrogens, and here I have 2 water molecules. Okay, so what that means is I have to double my number of water molecules. So that means that I do twice this and another oxygen atom. And the reason I double the hydrogen is now I have 2 times 2. This 2 goes for, it's called the coefficient, multiplies through the entire way. So now I have 4 hydrogen atoms. And with oxygen, well, I have these 2 oxygens from carbon dioxide, and now I had 1 from water. Now I have 2 times 1, so I have 4. So now at this point, I have my carbons are all checked, my hydrogens are all checked, but now I have 2 oxygens on my reactant side and 4 on the product side. So what I need to do there is 2 times my number of oxygen molecules. So now, oxygen atoms. I need to be very careful. It's atoms there that I have. So if I double my oxygen molecules, it also doubles the number of atoms. So now I have 1 carbon on each side, check. 4 hydrogens on each side, check. 4 oxygens on each side, check. So now my balanced chemical equation tells me that I have, if I wanted to read this out as a sentence, I have 1 molecule of CH4 reacts with 2 molecules of O2 to produce 1 molecule of CO2 and 2 molecules of H2O. All right. And I could have also said here 1 molecule of gaseous CH4, or 1 molecule of CH4 as a gas reacts with 2 molecules of O2 as a gas. So I could have been even more specific with that. So I prefer this method where we have something like this. We have, it's going to give this chemical equation, NO2 plus H2O makes HNO3. That's nitric acid. It's really nasty. We'll do this. Liquid AQ plus NO gas. No gas. All right. So here's the way I think through. It's very similar to that atom inventory idea, except I actually draw it out. I could say write it out too. So I count 1 nitrogen on my reactant side, 1, 2 on my product side. So I know I need more nitrogen gas. So let's see. I'm going to put another, actually write one underneath. Okay. So now, erase this. I have 2 nitrogens on each side. Now I'm going to check. I tend to do oxygens last. There tends to be more oxygen than anything else in these chemical equations. So I tend to do that last. So I'm going to go over to my H's. So on this side I have 2. On this side I have 1. Well, that means I need another nitric acid, HNO3, over here. So now I have 2 hydrogens on each side, but that also screwed up my nitrogens. So now, on the left side, now I have 2 nitrogens over here, but I have 2 plus 1, which is 3 over here. Oh man, got to add another nitrogen dioxide over here. So now I'm back, and I know this is a little confusing, but the more you practice this, it'll be better. It won't be bad at all. So my nitrogens are now back to being all set. 3 nitrogens on the reactant side, 1, 2, 3 on the product side. So last we'll check the oxygens. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So now my atoms are completely balanced and inventoried. So I have 3 here, 1 here. You can leave this out. You can leave out the 1, it's assumed. 2 here and 1 here. So what you'll notice is that while my atoms have been balanced, the coefficients, these numbers in front haven't. I have 3 and 1, which is 4, 2 and 1, which is 3. Those numbers don't have to add up. The key is that the number of atoms of each type you have on one side has to equal the number and types of atom on the other side. Okay. So coefficients versus subscripts. So the coefficients are the number in front, and you can change this. You can change the coefficients. So I would pause the video right now, write down this chemical equation. Did you pause it? Are you sure? You have it all written down? Okay. So these numbers in front, in terms of this is the combustion of propane, this is stuff like in your grill. The coefficients that you could change are these numbers in front. The subscripts, you do not change these. Do not change when you're balancing a chemical equation. So the reason you don't change that is because if you change the subscripts, you're actually getting new materials. Like if I changed H2O, if I were trying to balance the H's and instead of H2O, I wrote H3O, well, that's not water anymore. So you cannot change the subscripts. You can only change the coefficients. And we're going to practice this a bunch in class if you don't have it right now. Numbers in front, you can change to balance. The small numbers, the subscripts, you cannot. All right, how do you balance atoms in a chemical equation? So the number of atoms on both sides must be equal. When an equation is balanced, it tells you how many molecules are formula units. Remember, molecules is covalent, and FUs are ionic. Of each substance, take part in a reaction, and how many would be produced. Subscripts show how many atoms are bonded together within each molecule or formula unit. So you change the subscripts, you're actually changing the chemical properties, and you're getting a new material, which you cannot do just by which you do not do in balancing chemical equations. Okay, and that's it for now.